I would like to introduce to you Yusuf Muhammad. Yusuf is a co-inventor of Automist Plumis award-winning water mist suppression system. He has an honors master degree in engineering and a double master's in innovation design engineering. He has won numerous design awards for a host of innovations across a number of industries, including the James Dyson Award, the Toyota IQ Design Challenge, and Transport Design of the Year by the Design Museum, to name a few. He also starred in the BBC Two show The Big Life Fix. Yusuf's presentation is entitled Automist for Sheltered Social Housing. The stage is yours, Yusuf.
Okay, thank you for the introduction, Bettina. A little bit more about me. So, I mean, I'm an engineer by background, but I've always been interested in innovation and trying to solve problems with design. I formed the company with my co-founder, William, just over 10 years ago. I was studying at Imperial College London and the Royal College of Art, and William was studying his MBA at Imperial College at the time. And as both graduate engineers, we got really interested in trying to make a difference in an emergency situation and rethinking some of the approaches to active fire suppression. So this really began with an exercise to try and understand the landscape of fire safety. And the first thing that we did was highlight and examine how a fire problem is evolving. The first thing that we noticed was that modern fires are different to fires of old. The introduction of modern methods of construction means that you have less heat, fires don't burn as quick, but there is a well-documented impact on the toxicity of smoke. Hydrogen cyanide, for example, is 35% more dangerous than carbon monoxide. We also see the densification of housing. Overcrowding is listed as one of the fire risks by the English Housing Survey, for example, as we're struggling to keep up with demand. And aging populations all around the world are affecting fire statistics, given that those above the age of 80 are more disproportionately higher in their in how they are affected by dangerous fires within the home. We're also seeing changing habits in causes of fire. Smoking and chip pan fires have reduced in recent years, although they're still not at a level that we would like, and this in part due to changes in behavior. But more recently, we're seeing an increase in both electrical fires and white good fires, and a more common one is lithium-ion batteries. So this really just illustrates how the landscape is evolving all of the time. Now, when we're thinking about sheltered housing and vulnerable individuals, I like to show this video because it really illustrates the circumstance. It's quite a shocking rescue that took place in a care home. And thankfully, there was attendants on hand to escort this gentleman out of the fire. But it does show how we do need to think differently and really try to understand the scenario where this sort of thing happens. Fires in these environments can grow very quickly, and who knows what would happen in a situation like this if there wasn't care or support available to help this gentleman escape. So this is very much aligned to some research which was done by the BRE just recently, where they examined all the causes of fire fatalities and serious serious fire injuries in Scotland. And the document came to a number of conclusions. First, it said that current technologies and approaches may provide insufficient protection, that aging populations and vulnerabilities with increased vulnerability need more sophisticated ways in terms of being protected. And it pointed to early detection and suitable intervention as two methods to delay the development of fire and to notify people. This is something we at Plumis have taken to heart and are really kind of looking into. So the next thing when thinking about elective fire safety upgrades, so when looking at already code compliant buildings and asking the question, well, how can I enhance safety? How can I offer a greater level of protection to anyone who's staying there? Is to really frame the situation, understand the situation into where you're making an intervention. So that involves asking two questions. The first one is really trying to understand the housing stock and its characteristics. Is it a new build or is it an old build? Is there a water supply available? Can I refurb the premises all at once? Is a phased approach better? Is asbestos in the ceiling? How does the fire loading vary? These are all questions which can be should be asked. Alongside that, there should be consideration of the occupants. This might take the form of a person-centered risk assessment. You might speak to those individuals, find out how easy it is to get them to buy into a active fire suppression system. How will they be affected if the system activates? Do they have the ability to activate? Even from a fire engineering point of view, is the tenability limit lower because of limited mobility, for example? And I think it's asking these questions that you can find out the nuances on a case-by-case basis for each installation. So our, say, entrance into the industry was very much inspired by work which was done previously into Automist. This is something which has been talked about earlier in the talk in the presentation. But water mist is so powerful because we're using smaller droplets of water. What happens is that primarily the water turns to steam, and in doing so, that displaces the oxygen that feeds the fire, as well as getting rid of the heat. So that's addressing two corners of the fire triangle. And it is particularly powerful in this particular situation because it can be used on a broad range of fire types. So I mentioned earlier electrical fires, white goods fires, which are concealed. Because water mist is almost a halfway between a wetting and a gaseous system. It has some traits that lend itself well to these kind of modern domestic fires. Now, our system is unique in its approach. What we do is we mount our nozzles lower down on the wall, about light switch height, and we target the fire specifically. So we have an initial trigger, which is your early warning alarm. We then scan the room through 180 degrees, and then we target the fire's location with a blade of water mist. And this approach means we can use 10 times less water than a traditional sprinkler. Okay, so really to kind of explain, so you can kind of get your head around the way in which our system is put together, we have a controller, which is a computer, the brain of the system. That is connected to a pump. This pump is quite small. It's about the same size as a kitchen kettle. And from there, you would connect it to your existing water main. So no need for a tank. In the vast majority of installations, you can run off the existing water supply because it uses less water than a power shower. And then from there, you would run your high pressure hose to up to 6 heads uniformly distributed throughout the property. And as I said before, a key part to this is the integration of the detection. So you can send a message if the system is activated or if there's smoke or heat building up within the premises. One of the distinctions that I'd like to make, or at least illustrate, between traditional sprinkler systems and water mist systems is the physics behind their approach. Now, we learned this 10 years ago when we were at the very first International Water Mist Association conference in the UK at the BRE, where we met this man, Professor Ragnar Vigas. And he said to us, well, look, if you're going to start developing water mist systems and you want to use them in the most efficient way, then you should utilize Archimedes' principle. Now, just to explain this, traditional sprinkler systems, what they do is they use Newton's law, gravity. They use large droplets, and they're attempting to wet all of the surfaces in the room, not only to get water into the base of the fire, so these large droplets going against the updraft that the fire creates, but also wet all of the areas around the fire so that the fire has nowhere to grow to. Um, all of those materials are completely soaked. Now, water mist uses a different mechanism. It uses Archimedes' principles. So one of the challenges with mounting water mist nozzles in the ceiling is that you have to cool a hot layer on the ceiling before you address the fire. Now, this is not to say that water mist nozzles from the ceiling don't work. Of course they do, but it is not as efficient because you're cooling that hot layer before you're addressing the fire. So this is our approach has been to find a happy medium between the floor, which is the optimum position, and the ceiling, where we get enough water mist to tumble over obstructions, but we can still produce, ensure that there's a significant amount of water mist in and around the base of the fire. So as that fire tries to grow, those mist particles get entrained into its natural turbulence, turn to steam, and you get that powerful suppression and even extinguishment sometimes, depending on the fire load, taking place. There's this difference in principles between water mist and traditional sprinklers that we are trying to make the best use of. The other thing that is different with our approach is how we initiate activation. So here we've got a fire engineering heat release curve. It shows how a fire progressively develops to flashover and your risk increases progressively. So initially smoke, smoldering, you have smoke, flame, heat. And our objective, particularly in sheltered accommodation, we're thinking about life safety, is to get everyone out well within our available safe escape time asset. And we do this by making sure that the tenability limit, so this is a measure of survivability, is not breached. Now, this can be challenging, um, particularly when you're triggering your suppression solely using heat, because you potentially have an incubation period where you're building up a lot of smoke within the premises, and you're also reliant on a significant buildup of heat in the room of origin before your system operates. What we're trying to do with our system is twofold. The first thing that we're doing is initiating that detection. That can be connected to a communication device to send a message. And the other thing that we want to do to maximize the activation time is operate at the earliest possible time, well within that tenability limit. Now, just to illustrate that, here we've got some testing which we did at the Fire Protection Association. In the left, we have a room protected by Automist Smart Scan, and on the right, a room protected by a traditional ceiling-mounted sprinkler, so a fast-acting bulb. And they're identical fires. We know they're identical because we measured the thermocouple, the temperature data. And you'll notice that the fire on the left in the room protected by Automist, we were able to operate 2 minutes before the residential sprinkler. And that's because we're using our electronic sensor, which is looking for change in temperature over time, as opposed to our ceiling mounted glass bulb, which is looking for the ceiling temperature to go above a certain threshold before it activates. There's also some additional benefit in that the fire is concealed and shielded, and water mist, as I said, with it using that Archimedes principle, we get some entrainment taking place where it's a bit more difficult for the sprinkler in this particular fire to get that water in and around the base, given the fact that it's underneath that work surface and partially shielded. But of course, it is still an effective way of suppressing fires. It just takes a little bit longer and uses more water, which has impact on consequential water damage. So this is one of the attributes that some of our customers appreciate and why it was utilized in sheltered housing. Okay, so if I go on here, I would like to illustrate a case study. This is in a London borough where they're using our system to enhance safety. As I said, one of the primary reasons that they've been using the system is because of limitations of water supply on site. So in the UK, you have a minimum guaranteed supply by the Office of Water Services, Ofwat. So they guarantee in residential and domestic buildings that they will provide you 9 litres of water per minute and a single bar pressure. That is their obligation, whether it is Thames Water or Severn Water, whoever your water provider is. And Automist offers a unique attributes because we were only drawing 5.6 litres when we activate a single bar. So under that threshold, whereas with a traditional sprinkler, you're going to need significantly more, which means typically you either need a commercial water feed, an upgrade to your existing supply, or a tank. So we were selected because it meant that they could address the risk in these particular buildings with a head in the kitchen, the living room, and the bedroom, as well as that detection. And installation was fairly straightforward and could be done in a single day. So the key parts, the first and the key parts of the installation is installing it on a separate circuit, so that it's not going to be tripped if there's an electrical fire that trips the fuse, say, in the protected space. It's on an entirely independent circuit. You've got your pump connected to the mains water with your filter there, your check valve. And from there, you can either run your hoses within the wall, so behind that fire barrier there, or within fireproof trunking, and then you have your individual heads. We have a commissioning procedure where we test the flow on each one of those individual heads, as it's the only way you can be confident that the system will perform when called upon. So here you can see some more pictures of installations. We've got our heads, either mounted within plasterboard or, as I said, within this fireproof trunking, discrete within the space. And the pump there is in a storage cupboard with your circuit board. And again, this is mounted underneath a fireproof box. So this just gives you a bit of a sense of how the system can be deployed in a sheltered housing example. So finally, I'd just like to explain, what we're trying to do as a manufacturer, and why there's benefit in this approach. So we make things slightly difficult for ourselves when it comes to the sales process by doing things differently. And our approach has been to do differently to what most manufacturers do, which is they focus primarily on the standards. So the standards present a really important benchmark, but historically the objective of these systems, of traditional sprinkler systems, was to provide property protection and to limit the fire to the room of origin. So standardized testing is focused around this particular objective. Now, that's not to say that they cannot be used for life safety. Of course they can. The fire performance can also be fire engineered and applied in different ways. But I say this because this was one of the initial design objectives of traditional sprinkler systems. And what we're looking to do with Automist is elevate the system with a slightly different objective, where we meet this initial benchmark, but go further, looking to address things like ease of retrofit, so we can have greater adoption of active fire suppression systems, minimize damage, and also look to increase survivability in the room of origin through early activation and smart detection. We even are thinking about how we can provide homeowners, stakeholders, more value by utilizing our sensors to do things like perhaps control your thermostat or monitor temperatures within the room. So we're trying to think about a specific objective and how we can optimize our system to meet the needs in that particular scenario. So thank you very much for listening. If you do have any further questions, feel free to drop us an email or visit our website.